Hello everyone, welcome back to my YouTube channel. So today we are going to solve question number 1 of weekly contest 455. Check if any element has prime frequency. And we are able to pass all the test cases and able to submit this problem. So now let's read the problem statement first. You are given an integer array nums. We have to return true if the frequency of any element of the array is prime. Otherwise we have to return false. The frequency of an element x is the number of times it occurs in the array. A prime number is a natural number greater than 1 with only two factors, 1 and itself. Alright, so now let's understand this problem statement with an example. Right, so here this is my nums array. So here in this nums array, if you see, the frequency of 1 is just 1. The frequency of 2 is also 1. The frequency of 3 is also 1. The frequency of 4 is 2. And the frequency of 5 is 1. Okay, right. So here now we have to check all the frequencies, right? We have to return true if the frequency of any element of the array is prime. So 1 is not a prime, 1 is not a prime, 1 is not a prime. Okay, and this 2 is a prime, right? So that is why we are returning true. So 4 has a frequency of 2, which is a prime number. Okay, and what is prime number? A prime number is a natural number which is greater than 1 with only two factors, 1 and itself. Okay, so for 2, 1 and 2 itself, that's it. Okay, has only two factors, 1 and itself. Okay, all right. So now here see this example number 2. 1 frequency is 1, 2 frequency is 1, 3 frequency is 1, 4 frequency is 1, 5 frequency is 1. Return false. Here 2 frequency is 3. Okay, and 4 frequency is 2. So here we have to just simply return true, right? Both 2 and 4 has a prime frequency. Okay, what are the prime numbers first? So prime numbers are 2, 3, 5. Okay, these numbers we can divide them by 1 or by itself. Okay, 7, then 11, then 13, then 17. Okay, then 19 also, right? 23. Okay, and so on, right? So here if you see the constants, so nums dot length is from 1 to 100 and numbers are from 0 to 100 only, right? So we can simply create one frequency array and we are going to check the frequency of all the numbers starting from 0 until 100, right? Okay, so what I'm going to do, let's see the code. So here this is your code, okay, main code. So I'm going to create one frequency array, right? And I'm going to pass this 101 because we are assuming, not assuming, because the constants are given to us from 0 to 100, right? So values in nums are between 0 to 100. Okay, so this is given in the constants. All right, okay, after this we are just going to count the frequency of each number, right? So we are going to use for each loop. So here I'm just iterating over all the values in nums, and one by one I'm calculating the frequency, right? And once I calculate all the frequencies, then I'm going to check if any frequency is a prime number. So I'm just iterating over all the frequencies again and again, and here I'm calling this is prime. Okay, and I'm checking if the frequency is a prime. Okay, if it is prime, then simply return true. Okay, and in the end, if we still didn't execute this return true statement, then simply return false. Okay, and here this is your helper function to check if a number is a prime. So here what I'm doing, so if number is less than 2, then just return false. Okay, and otherwise we are just going to run one for loop. Okay, starting from 2, and here divisor value, it should be less than equal to math dot square root of number, right? And divisor plus plus, we don't need to check all the numbers. Okay, this is fast. Okay, until here only we need to check. And here if number modulus with divisor is equal to 0, then return false, otherwise return true. Okay, and I hope that you guys are already know why we are just running until math dot square root of number. Okay, if not, let's understand that also. Okay, so here uh, first, what is a divisor? Okay, so a divisor of a number n is any number d that divides n without leaving a remainder, right? So n modulus with d it should be equal to 0, right? So a divisor of a number n is any number d that divides n without leaving a remainder. Okay, in other words, d is a divisor of n. That simply means n modulus with d is equal to 0. Now here, if I ask you to calculate the divisors of n is equal to 12, so you are going to say that we can divide this 12 with 1, we can divide this 12 with 2 also, right? We can divide this 12 with 4 also, we can divide this 12 with 6 also, right? So here how you calculate the divisor? So here if you see here 2 2 6 12, okay, here 2 3, and here 3 and 1, okay. So here this 2 3 and 1, okay. So here this 2 2, okay, I can say simple 4, right? And here this 3, okay, and this one, okay. So distinct, if you say, you can say 2, right? 2 2, I am dividing it 2 3 and 1, okay. So here I can say 1 into 12 is 12, okay. 2 into 6 is also 12, 3 into 4 is also 12, right? Okay, so we have covered all, right? 1 2 4 also is here, right? And 6 also, and with 3 also, right? We can do this with 3 also, right? 3 4 12, okay. So here if you see 1 is there, 2 we no 3, okay, 4 6 and 12 itself, okay. 12 itself is there, right? Okay, so the divisors are 1 2 3 4 6 12, okay. Clear, right? And these are different ways to write. Okay, 1 into 12 is 12, 2 into 6 is equal to 12, 3 into 4, after that 4 into 3, but that scenario is already covered now. 4 into 3 is also 12, but that is already covered here, right? 5, then 6 into 2, so 2 into 6 is already there, then 6 into 2 is same now, okay. So here if you notice, they come in pairs, okay. Only three distinct pairs are there. One is 112, 2 6, 3 4, okay. 4 3 is simply means 3 4, right? Okay, I can say, right? 6 2 is 2 6 only, right? So each pair multiples to 12 only, right? Okay, so what does this mean for checking prime? So if a number n has a non-trivial divisor, it comes in a pair d and n by d, okay. So d n by d, okay. So d is 1, n by d 12 by 1. If d is 2, then next is 12 by 2, okay, right? If d is 3, then next is 12 by 3, okay. This is what, right? So if one number is in the pair is greater than square root of n, then the other must be less than square root of n, right? So example here 49. So for 49 we are just checking from 2 3 4 5 6 7, right? Okay, right? So you didn't need to check after 7 like 8 9 10 48, because if any d greater than 7 divides 49, the other number in the pair would be less than 7, and you already checked those, okay. So that's the reason, right? So if n is not a prime, it must have at least one pair of divisors, d into n by d is equal to n, and in every such pair, one is less than equal to square root of n and other must be greater than equal to square root of n. So to check if n is a prime, just we have to check until here only, right? So I hope that you guys are clear with this also, why we are running the loop until square root of n, right? So I hope that you guys are able to understand question number 1 of weekly contest 455. If you guys still have any doubts, then please ask in comment section. Thank you. Bye bye.